Welcome to Algebra 2, Podcast 2.2, Finding Slope and Rate of Change, and 2.3, Graphing Equations of Lines. First thing we want to talk about today is slope. The slope m of a non-vertical line is the ratio of the vertical change, which is the rise, to the horizontal change, which is the run. You probably know it as rise over run. There's a couple different ways you can calculate slope. For instance, if you know this formula, slope m is equal to y2 minus y1 divided by x2 minus x1, you can use that. Or if you have a graph, you can actually count your slope. However, if you don't have a graph, you would have to use the formula. Let's go ahead and let's find the slope by counting on our graph. So I'm going to locate a couple points. Here's a point and here's a point that are on the line. So I'm going to count my rise. 1, 2. So my rise here is 2. Then my run would be 1, 2, 3, 4, 5, 6. Run is 6. So if I set up that ratio of rise over run, my slope is 2/6, which can be reduced to 1/3. So my slope of this line is 1/3. Now, let's take a look at how to calculate it using the slope formula. If I want to use the slope formula, I actually have to know the location of the points. So my first point is here at 0, -2. My second point is at 6, 0. So I'm going to let this point be x1 and y1, and this one's going to be x2 and y2. It does not matter which one you let be your first point or your second point. It'll come out the same. So if I want to use this formula, I'd have y2, which would be my -2, minus the 0, which is my my y1, over my x2, which would be the 0 right here, minus the x1, which would be 6. So -2 minus 0 gives me -2. Over 0 minus 6 is -6. Again, which if you reduce it, you get 1/3. So again, we got a slope of 1/3. Again, it doesn't matter if you calculate it by counting or using the slope formula. Let's take a look at an example. Here I have a skateboard ramp that has a rise of 15 inches and a run of 54 inches. So I want to know what is the slope of this skateboard ramp. So I would simply put the rise over the run and then reduce if possible, and I would get that my rise is 5/18. And actually I meant that's my slope. So my slope is 5/18. Next, let's try one where we have two ordered pairs but no graph. So here I have the 2 points, 4, 3, and 2, -1. I want to find the slope that passes through these points. So I'm going to have my x1, my y1, and my x2, and my y2. So I would take -1 minus 3 over 2 minus 4. -1 minus 3 gives me -4. 2 minus 1 is -2, so my slope is a +2. Now again, as I told you earlier, you can do it the opposite direction. It doesn't matter. You get the same calculation. So for instance, if I change this to my x2 and my y2, and this is my x1 and my y1, I would have 3 minus a -1 over 4 minus 2, which would give me a +4 over a +2, so my slope is 2. Again, either calculation will give me the correct slope. Here I have 4 different graphs. This line rises as you read it from left to right. So this has what we call a positive slope. Again, because it rises from left to right, it's a positive slope. This line falls as we read it from left to right, so this has a negative slope. again, it falls from left to right, so it has a negative slope. Now these next two examples are a little bit different. This third example is a horizontal line, so this one has a 0 slope, because the rise here is 0. So you'd have 0 over some number, which would always give you a 0 for your slope. The fourth example is exactly the opposite. It's a vertical line, so you would have a rise of some number and a run of 0. Well, we all know that you can't have a 0 on the bottom of a fraction, so this is what we call an undefined slope. And there is an I right in there, you just can't see it. So that last one is an undefined slope. On these next examples, I want you to calculate the slope and tell me whether they rise, fall, or if they're horizontal or vertical. So you would calculate that using the formula. So I'd have my y1 minus my y2 over, and right there I'm looking at that, and that's going to give me a 0. So I'm going to get 0 on the numerator, and I'm going to get a number on the denominator. So because I get the 0 here, I know right away this is a horizontal line, so I'm just going to say that it's horizontal. Okay. Example B, same thing. I'm going to take my y2 minus my y1 divided by my x1 minus my x2, and I get a positive 4 over a negative 8. So my slope is negative, so this one's going to fall. Okay, on the third one, I've got my y1 minus my y2 and my x minus my x. I get a negative 5 over a negative 6. So a negative divided by a negative gives me positive. This has a positive slope, so this is going to rise. And last but not least, in example D, again, I take my y minus my y over my x minus my x. And I've noticed something again. My x's are the same, which is going to give me a 0 in the denominator, which again is not possible to do the math. So it has an undefined slope, so it is a vertical line. Now let's talk about slopes of parallel and perpendicular lines. Parallel lines in this first graph have a nice slope here. If we count this one, we've got a rise of 1 and a run of 2. So that was a rise of 1 and a run of 2. So the slope of this green line is 1/2. The slope of the second line, again, I want to pick 2 points. So if I pick this point, I rise 1 and run 2. So the slope of the second line is also 1/2. So parallel lines have the same slope. So slope 1 would be equal to slope 2. Again, parallel lines have slopes that are the same. Perpendicular lines, on the other hand, are a little bit more complicated. I want to pick a couple points and find their slopes. So my rise here is a negative 2. My run is a positive 1. So the slope of this green line is negative 2 over 1, which is a negative 2. The slope of the blue line, again, go ahead and count, is a rise of 1 and a run of 2. So the slope of the blue line is 1/2. So I've got 1/2 is one of my slopes, and negative 2 is my other slope. Now if you look at these, you can see that they are opposite reciprocals. So perpendicular slopes are opposite reciprocals. So in other words, if you took your slope 1 times your slope 2, you would get a -1. Okay, so let's take a look at that again. Perpendicular lines, slopes are opposite, meaning the positive and negative signs, reciprocals. Okay, parallel lines, slopes are equal. Perpendicular lines, their slopes are opposite reciprocals. It's very important that you remember that, so let's try some examples. Okay, so I have two different sets of points here in example A. I want to tell whether they are parallel, perpendicular, or neither. So we're simply going to use our formula, and we're going to find the slope of line 1 and then the slope of line 2. So slope 1 would be y2 minus y1 divided by x2 minus x1. So I'm going to get 3 over -2. Now let's find the slope of line 2. So I have slope 2. So I have a -1 minus 3 over -4 minus 2. That gives me -4 over -6. Again, a negative divided by a negative is positive, so that would reduce to 2/3. If I take a look at these very carefully, they are opposites because this one is positive and this one is negative, and the reciprocal of 3/2 is 2/3. So these two lines are perpendicular. So example A, the lines are perpendicular. In example B, we want to do the same thing. So I find my slope 1 by taking my y1 minus my y2 over my x minus my x, and I'll get 5 over -3. And then I want to find my slope of line 2, same exact way. 3 minus a -2 over -4 minus a -1. So I get 5 over -3. Now if you look at these two slopes are the same, so I know these two lines are parallel. Again, same slope means they're parallel. Let's try an application problem. Here we have, in 1965, the giant sycamore tree trunk had a diameter of 137 inches. However, in 2005, the giant sycamore tree trunk had a diameter of 141 inches. We want to find the rate of change in the sycamore's diameter over time. Then we want to predict the sycamore's diameter in 2065. Now, rate of change is a very important term, and that means the same as slope. So rate of change is calculated exactly the same way we calculate slope. However, before we can find the rate of change or the slope, we have to figure out which one of these things, the years or the inches, are the independent variable and which one is the dependent. And if you think about this, your independent variable is going to be the year, and your dependent variable is going to be the diameter. So my ordered pairs are going to consist of the years, 1965, and the inches, 137 inches. There's one of my points. My other point would be 2005, 141. Again, as I said, rate of change is slope, so we calculate this rate of change exactly the same way. So I'm going to take my y2 minus my y1, and again, as I showed you earlier, it doesn't matter which order you do them in, as long as the 141 comes first, so the 2005 comes first because they were an ordered pair. I'm just going to calculate this and simplify it. I come up with 4 inches over 40 years. And if I go ahead and simplify that even more, that gives me 1/10 of an inch per year. Okay, so the diameter of these trees is growing by 1/10 of an inch per year. So my rate of change is 1/10 of an inch per year. But I also want to calculate, or predict the diameter of the tree in 2065. So what I need to do is I need to calculate how many years that is from the 2005. So 2065 minus the 2005, that's 60 years. So if it grows 1/10 of an inch every year over 60 years, that would be 60 times 1/10 of an inch, and that would be 6 inches. Okay, so in 60 years, the tree's diameter is predicted to grow 6 inches. So in 2065, if the diameter was 141 in 2005, and we predict it's going to grow 6 more inches before the year 2065, in 2065 the new diameter will be 147 inches. Okay, again, rate of change is exactly the same as slope. It's calculated the same way. Now we need to talk about graphing equations of lines. So first I want to introduce you to the parent function. The parent function of a line is f of x equals x. In other words, y equals x. But remember, the function notation is read f of x. These two things, again, mean the same thing. It's just the first notation, f of x equals x, tells you it is a function, and the second one, you don't actually know that. You have to think about it. However, hopefully, you do recognize that y equals x is a function. So I have over here the graph of the parent function. So this is the graph of the line f of x equals x. I want you to take a look now that we've talked about slope, and I want you to figure out what the slope of this line is. So if we look at this line, I rise 2, I run 2. If I rise 3, I run 3. So the slope of this line is 1. So the parent function has a slope of 1. I also want you to recognize where the parent function crosses the y-axis, which is what we call the y-intercept. So this line crosses the y-axis right here at 0, 0. So my y-intercept is 0. It's very important that you understand that the parent function of a linear function is f of x equals x, meaning the slope is 1 and the y-intercept is 0. Let's take a look at what happens when we put some numbers into the parent function. For instance, if we put a 2 here in front of the x, let's take a look at what happens. So this blue line is my parent. So that's the f of x equals x. So the second function, the one in green, that is y equals 2x. So what has changed? If you look at these two functions, you can see that in the parent function, our slope was 1. Well, what is the slope in this new function, y equals 2x? Well, we can count it. So my rise would be 2, my run is 1. So my slope is 2. Notice there's a 2 right here in the function. Now let's take a look at what happens when we change this part of the function, when we add a number to the parent. So again, my blue line is my parent. That's f of x equals x. And we know that the y-intercept of this line is at 0. Okay, what is the slope of the new function? So we can calculate the slope again. So if I rise 2, I run 2. So my slope of this one is also 2. So what's changed about this one? Oh, my slope, that's not right. That slope is not correct. I rise 2, I run 2, so my slope is actually 1. which is exactly what I wanted it to be. So this second line, the green one, has the same slope as the parent. So hopefully right now you're all thinking, oh, that means they're parallel. Yes, they are parallel. So what has happened, what's the difference between the parent and the new line that makes it parallel instead of, for instance, the same line? So you notice that the y-intercept is different. The y-intercept of my new line is 3. And here's the 3 in the equation. So whatever number we're going to add or subtract to the parent changes the y-intercept. Okay, so in conclusion, if I multiply something times my x, this number will change the slope. And if I add or subtract a number out here, this is going to be the y-intercept. Let's take a look at how you use the slope-intercept form to graph. First of all, you should all know that the slope-intercept form is y equals mx plus b. This should be review for you. The first thing you want to do is you want to change your y-intercept, change your equation to slope-intercept form. So over here I have an example. I would subtract my 2x from both sides. And then I need to divide both sides by that negative 5. So y is equal to positive 2/5 x plus 4. So I've changed it to slope-intercept form. First thing I need to do is identify my y-intercept, which is the b. So what is the b of our new equation? Well, that b would be the 4. So now we're going to plot a point at 0, 4. Now normally I would be using a straight edge, but I don't have one. So I'm going to try pretty hard to get some straight lines. So my y-intercept is at 4, so I'm going to go up 1, 2, 3, 4. So here's my y-intercept. The third thing I want to do is identify my slope, which is my m. And if you look at that equation again, your m, your slope, is with your x. So my slope is the 2/5. So from this point, this y-intercept point of 4, I want to use the slope of 2/5. So I could rise 2, 1, 2, run 1, 2, 3, 4, 5, and have a point here. Or I can do the opposite. I can rise a negative 2 and run a negative 5, which puts a point here. I now have 3 points, and the last thing I need to do is to draw a line through those 3 points. Again, you should be using a straight edge to do this, and I'm trying my best. I kind of missed that last point, but that should be pretty good. So this is my line, y equals 2/5 x plus 4. Let's take a look at graphing using the standard form. As you may recall, the standard form is ax plus by equals c. Over here, I have an equation in slope-intercept form, and I want to put it in standard form. What I'm going to do is I'm going to use what I call fraction buster, and I'm going to multiply everything by 5 to get rid of my fraction. So I now have 5y is equal to 2x plus 20. I'm then going to subtract my 2x, and I get negative 2x plus 5y equals 20. But in standard form, you cannot have a negative a, so I'm going to change all of my signs. And here's my new equation in standard form. 2x minus 5y equals negative 20. Step 2, I want to identify the x-intercept by allowing the y to be 0. So if I substitute a 0 in here for the y, I have 2x minus 0 is equal to negative 20. So my x-intercept will be negative 10. Now I want to do the same thing to find my y-intercept, but this time I'm going to let the x equal 0. So I have 2x minus 5y is equal to negative 20, but I'm going to let my x be 0, which causes this to become 0. So if I solve for y, I would get a y-intercept of 4. The last thing I want to do then is to draw my line with a straight edge through those 2 points. So let's go ahead and locate our point 0, 0. Now my x-intercept is negative 10, so I think I'm going to put 0, 0 clear over here. Which, by the way, is perfectly fine. You can put your 0, 0 wherever you want it. So my x-intercept is negative 10. And that's right here. My y-intercept is 4, so I'm going to count up 4. And my y-intercept is right here. And then again, I want to draw a straight line between the two and make it as straight as possible. Again, you should be using a straight edge. And you can see that I missed that point. But again, if I had a straight edge, I would have made sure that it went through those 2 points exactly. And I don't have an eraser here, so I can't really take care of that. Okay? So be sure you use a straight edge and make it go through the 2 points. The last thing that I want to do is I want to go over horizontal and vertical lines. A horizontal line, the graph of y equals c is a horizontal line. So if I had y is equal to 5, that would be a horizontal line at 5. So again, I'm going to draw in my 0, 0, my origin, and I have a horizontal line at 5. So here's 5, so I'm going to have a horizontal line here. And that is y equals 5. Down here, a vertical line is in the form x equals c, where c is a number. So if I had x equals negative 2, I would have a vertical line at negative 2. So I'm going to locate my 0, 0, and then locate an x of negative 2, which would be right here, and then I'm going to draw in my vertical line. Again, you should be using a straight edge. Now, it's time for you guys to give this a try. But first, we have to give recognition to our textbook company. Thank you, and I'll see you back in class.